Hello, listeners. This is Mike, your host. If you are enjoying these archive episodes, please consider supporting the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. Hopefully, with your support, I can continue to release these archive episodes. Thanks. Hello and welcome. This is Michael Annis, and you're listening to episode 159 of the Space Rocket History Podcast. And now, Zond 6. Recall from episode 153, we covered the Zond 5, which was a Soyuz model 7K-L1. The 7K-L1 was based on the Soyuz 7K-OK, with the orbital module and the docking hardware removed, so the payload was in the descent module. The orbital module was replaced with a support cone and a high-gain parabolic antenna. Also, the reserve parachute was removed. The descent module was just big enough to carry 2 cosmonauts. Zond 6 was the official designation for the Soyuz 7K-L1 serial number 12. It was almost identical to Zond 5. It was supposed to photograph the moon in color and black and white from 8,000 kilometers and 2,600 kilometer ranges, then return to Earth, landing at Tyratam, only 16 kilometers from the launch pad. Equipment was included to study the effects of radiation on living creatures, although I could not find a description of the biological payload. There was a photo-emulsion chamber to record the paths of cosmic rays and a device to measure the impacts of micrometeorites. It was also an important test of the L1 guidance system. The launch vehicle was the Proton K carrier rocket with a Block D upper stage. It was designed and built at Vladimir Chalomy's Design Bureau. The Proton was 53 meters high with a diameter of 24 feet. It could be configured with 3 or 4 stages. It was just powerful enough to send a 7K-L1 around the moon without going into lunar orbit. The 7K-L1 would use a free return trajectory to return from the moon. The unmanned Zond 6 was launched from Tyratam on November 10, 1968 at 1911 Universal Time. This is how the Associated Press reported the launch. Title of the article is Soviets Launch Unmanned Space Ship, Zond 6. The Soviet Union has launched another unmanned spaceship, Zond 6, toward the moon, but has not disclosed the exact purpose of the flight. An official announcement said the spaceship was launched Sunday to conduct scientific exploration along the route of the flight and in near lunar space, and to test systems and units of the spacecraft. The launching came 7 weeks after an unmanned Soviet Zond 5 made history's first flight around the moon and back to the Earth, and followed by 2 weeks cosmonaut Georgy Beregovoy's Earth orbit flight in a Soyuz spacecraft. This activity seems to indicate an intensification of the Soviet effort to send a man to the moon." End quote. After a successful launch, the Block D stage put Zond 6 on a translunar course. A mid-course correction on November 12th resulted in a loop around the moon at an altitude of 2,420 kilometers on November 14th. Photographs of the lunar near side and far side were obtained with panchromatic film. Each photo was 130 by 180 millimeters. Some of the views allowed for stereo pictures. The photos were taken from distances of approximately 11,000 kilometers and 3,300 kilometers. However, only one negative was recovered from the camera container. More lunar photographs were taken with a standard aerial camera, which had a focal length of 400 millimeters, a frame size of 13 by 18 centimeters, and a resolution of 50 lines per millimeter. While Zond 3's facsimile pictures could provide 1.2 million data bits per picture, each Zond photograph had 134 million data bits. The film itself measured 29 centimeters and 28 meters long. 2 orbital corrections were made on November 14th after the passage around the moon. But trouble began on the 6th day of the flight, November 17th. The capsule developed an atmospheric leak, the pressure first dropping from 760 to 380 millimeters. With the drop in cabin pressure, all the animal test subjects died, and it would have killed any cosmonaut not wearing a spacesuit. Which brings us to re-entry. Zond 6 used a relatively uncommon technique called skip re-entry to shed velocity upon returning to Earth. But first, why did the Soviets have to use the skip re-entry? The Russians explained that the South Pole approach was the only practical one for returning Zond payloads to the Soviet Union because a direct ballistic approach would bring too heavy an overload for a human crew, something like 16 Gs. The southern approach permitted the long double entry skip return, keeping the Gs in the 4 to 7 range. The negative effect was that the prolonged re-entry increased the effect of heat flow and added a considerable strain to the structure of the heat protecting system. Zond 6 returned to Earth in the same manner as Zond 5, with one important difference. It approached at 11 kilometers per second, used aerodynamic braking to slow to 7.6 kilometers per second, and then the control mechanism on board was used to orient the craft so that it developed considerable lift and skipped outside the atmosphere again. Then it made a second re-entry into the atmosphere. But of course, there was still the pressure leakage problem. It had now reached 25 millimeters, and due to the near vacuum condition, static electricity built up in the spacecraft's electronics. A coronal discharge sent an erroneous signal indicating that the gamma altimeter had sensed the approaching Earth, even though the capsule was at 5,300 meters altitude. This tripped the soft landing rockets, and that followed by jettisoning of the parachute. The capsule plummeted to Earth. Fortunately, the self-destruct system did not explode when the capsule hit the ground, and the Soviets were able to recover the film cartridges from the wreckage. On the positive side, the orientation system worked well, allowing for a crash landing in the Soviet Union in the target area. This was an impressive achievement for the descent module to use the skip entry to travel so many thousands of additional kilometers beyond the point of ballistic entry. This was a very impressive achievement because the descent module executed the skip re-entry to travel many thousands of additional kilometers beyond the normal point of ballistic re-entry. For propaganda reasons, the Soviets claimed the flight was a success. The formal announcement said that Zond 4, 5, and 6 were all aimed at perfecting a manned spaceship to go around the moon. Although all the indications were that Zond 6 performed well, the Soviets said that further unmanned tests would be required before men could be sent. The pictures of the Earth and the Moon taken by Zond 6 were published, and the world was told the mission was a complete success. This is how it was reported in the Chicago Tribune. The Soviet Union today announced that it had broken through one of the chief barriers standing between a Russian cosmonaut and the moon. Without mentioning the possibility of manned flight, the Russians reported their first test of a sophisticated re-entry system generally considered necessary for a safe recovery of a manned spaceflight to the moon, the system to be used by Apollo 8 next month. The vehicle was their Zond 6, which last week became the second unmanned ship to circle the moon and return to Earth. Tonight's announcements said it had performed the complicated re-entry and had landed in Soviet territory. The announcement avoided describing the landing itself, thus leaving open the question of whether it had been a soft landing. The description of an unmanned landing last month had referred pointedly to the successful testing of a soft landing system. The announcement did not say when the ship landed. German scientists reported tracing the ship on re-entry yesterday. The Russians reported only that the flight was launched November 10th and had lasted almost 7 days. The re-entry test was one which American scientists said more than a year ago would be likely for Russia before attempting to put a man on the moon. It consists of skipping the returning spacecraft through a slice of Earth's atmosphere and into space again to slow it down before it finally enters the atmosphere to land. The maneuver is considered the most practical method of slowing a lunar ship to a speed at which the negative gravitational forces encountered upon landing would be within the limits of human endurance. The only alternative, firing retro rockets to slow the ship to re-entry speed, would be impractical, scientists say, because the rockets would have to be too big. Zond 5 circled the moon and returned September 22nd in a high-speed path too fast for human endurance, but which was intended to test a new type of heat shield. It landed in the Indian Ocean. American experts reported as early as a year ago that the shield test and possibly the skipping maneuver would precede a manned Soviet lunar flight. Completion of these tests, however, does not indicate how near the Russians are to beating American astronauts to the moon or to moon orbit. It is not known whether Zond 6 has the capability of supporting cosmonauts. The Russians have not yet demonstrated the capacity to maintain 24-hour communication with a manned spacecraft as the United States has. They are not known to have a capsule capable of landing and taking off from the lunar surface, or a carrier rocket big enough to launch it from Earth. End quote. Now I want to move on to the analysis and consequences of the Zond 6 crash. Deputy Chief Designer Boris Chertok called the crash of Zond 6 extremely annoying. During analysis, it was determined to be an engineering error. There was a leak in the capsule due to a bad seal in the edging strip around the hatch. After power was supplied to the landing system, a corona discharge occurred in the gamma ray altimeter circuit due to the low pressure. It issued a false command to start up the soft landing engines and simultaneously to shoot out the parachute. Chertok felt particularly responsible for the unforeseen occurrence of a corona discharge in the gamma ray altimeter. He called it a blatant oversight that he had committed along with his subordinates working on the landing system, which was the Leningrad Polytech Institute, OKB-1, was supervising. Professor Yurovich, the chief designer of the gamma ray altimeter, admitted that no one had tested the electrical reliability of the system at low pressures. The gamma ray altimeter was supposed to activate as the descent module neared the ground. The instrument was supposed to be non-operational until the module reached an altitude of 5,000 meters. The pressure in the descent module was also supposed to be normal. Otherwise, the cosmonauts would die. It never occurred to anyone to test the altimeter at a pressure of 25 millimeters of mercury. On December 27th, OKB-1 had to give an account of the L-1's failure to the State Commission. Professor Yurovich came forward with a confession accepting full responsibility for the occurrence of the corona discharge. One complaint was lodged against Boris Chertok, which was the engineering specification had mentioned high vacuum conditions, but nothing had been said about the pressures at which a corona discharge would occur. The State Commission verbally castigated Yurovich and OKB-1, but there were no retaliatory organizational consequences. The fact of depressurization aggravated everyone more than the corona discharge. The State Commission decided to execute the next unpiloted launch of Vehicle 7K-L1 serial number 13 with the objective of a circumlunar flight on January 20th, 1969. As the State Commission session was coming to a close, someone loudly asked, "Why should we launch number 13 at all? After all, tomorrow 3 Americans are returning to the Earth after orbiting the Moon. If, God forbid, something happens again to our L1 spacecraft, our launch will be considered a failure of our lunar landing program." This was the opinion of many of the members of the State Commission, but no one uttered a word in reply. In conclusion, Zond 6 took spectacular photos of the Moon with the Earth in the background. Photographs were also taken of the lunar near and far side with panchromatic film from distances of approximately 11,000 and 3,300 kilometers. The 7K-L1 then made the first successful double skip trajectory, dipping into the Earth's atmosphere over Antarctica, slowing from 11 kilometers per second to suborbital velocity, then skipping back out into space before making a final re-entry onto Soviet territory. The landing point was only 16 kilometers from the pad from which it had been launched toward the Moon. But loss of atmosphere in the descent module and the crash landing after re-entry proved that the Soviets had not met the criteria for a manned flight around the Moon, and Chief Designer Mission's only hope to beat the Americans was a failure or delay in the Apollo 8 flight set for December. Thanks for listening to this archived episode of the Space Rocket History Podcast. If you are financially able, please support the podcast by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. Thanks.